Hey guys, so today you and I are going to talk about enterprise service buses and how they fit into SOA. So let's get into it. So the question in question was, Frederick, where does ESBs come into SOA? And the short answer is they don't have to be part of a SOA architecture, but it's very common that you have some type of message broker or ESB type of system when you're working with a distributed system. Let me explain that a little bit. So now we're getting into the deeper end of architecture, and this is way over a junior's head, most likely. So I'm just telling you that, warning you immediately before I go into this, because this is higher level stuff. This is something that the only time you're going to face this sort of challenge in your daily job is if you are at the very least this experienced developer and you're going to set up the infrastructure or the architecture within your system. This is something that senior coworkers usually do and juniors basically just consume. But I'm gonna give you the high level version of what's going on here and kind of explain a little bit why this is important. So usually the way it goes in software development, the life cycle of an application, as I like to call it, you can think about a application as just something that ages. So in the early days, when the system is very young, it's usually very simple. It's usually a monolithic application, something like that. And as the system grows, there is more and more code. And at some point, you're going to have so much code and so many people, if your company continues succeeding in the marketplace, that you're going to have problems with people getting in each other's way. It's a very common problem, and what we like to call it growth ache within a company, that you're getting unproductive and people are having merge conflicts with each other and so forth. And so what you do is that you start splitting the organization. Usually you start deciding that, well, we have 16 developers now. We can't have them all working in the same team because the meetings are going to take too long and not everybody's going to be able to talk at the stand-up, etc., etc. It just becomes a logistical nightmare. So what you do is that you split them and you say, all right, you're going to take a responsibility for one part of the code and the other team is going to take a responsibility for the other part of the code. And if these things are fairly isolated, you don't have to split immediately, but at some point you're going to split into the SOA architecture. And so the SOA architecture is just that you have multiple applications. You may know this term as microservices. That's not technically correct, but it's probably the best term because it's the trend term. So you split it into microservices. Now here comes the next problem, or rather the next step becomes, all right, so if you have two microservices talking to each other, that's pretty straightforward, because if they need to talk to each other, you know that, well, this service over here just needs to know one URL over to the other place, and that's it. And the same thing goes on the other way. But once the company starts growing even more, you're going to have 3 services, 4 services, 100 services. You kind of see the problem. And at some point you're going to reach this point where all of these different services needs to connect to each other in order to communicate something. The worst case scenario is usually that you might have something like, say, a user service. And let's say, for the sake of argument, that you have a feature now where the different systems within, the different services within your system, they need to know that a user registered to your application. Now, the naive way of implementing this would have been, okay, well, then we will just have a list of all the different services that we have within our system in the user service, and then that service will just call each of these different endpoints and just say, hey, there was a user that you registered, etc., etc., to each of these different services, right? That needs to know this. Now the problem with this is that this is both from an operations perspective and from a maintenance perspective an absolute nightmare, because if from the operations perspective, if any of those if you change anything, if you update any of the other services, now you need to remember that this other service depends on that the URL stays the same and that or at the very least that the IP is correct, right? that's a hard problem. And other things that can be really tricky there is that if you add another service that needs to know this as well, well, then you need to go and update the user service, because it's directly communicating with all of these other services. And from a maintenance perspective, it's also a horrible horror show, because if you can imagine, if you have 100 different microservices and one service needs to connect to all of those in order to make sure that they all have the information that they need in order for the system to work, well, if any of those network calls fail or anything goes wrong, you're going to have to track who got the message. And it can become even more complicated if it's very important that these things happen in fairly real time, so that it's fairly adjacent. So that becomes a problem. So what you do is that you introduce a message broker or a bus or like an ESB or something similar, where you have a layer which is usually a queue or something like that. You may have heard about them: RabbitMQ, Kafka, etc., etc. ActiveMQ is also popular. These different systems where what you do is that you put that application between all of your different microservices that need to talk to each other, and then you send a message to that broker, and that broker is now responsible for getting that message to the right place. And that broker can send it to one application, but it could also distribute it to multiple places. It becomes a what we call pub sub type of deal, where you can send one message and you can either send that to one other service or 100 different services. The service that is sending the message doesn't care. It just knows that, all right, if I send this to the queue or to the message broker, it's going to take care of the work for me. And that's the idea of an ESB or a messaging system or a queue system, call it whatever you want. It's something that is extremely common in larger scale systems, because it's practically impossible to maintain a large distributed system without having some way of sending messages between systems. The complexity here is, if you're going where you need to make a bit of a way off, is if you're going to send messages just for asynchronous messages, in other words, things that do not have to happen in real time, or if you're going to do it with both synchronous calls and with asynchronous calls. Because as you can imagine, if you have one message if you need to connect from one service to another service because a user just sent in a network request from a client or something like that, well, then that has to happen in real time, because as soon as the response, like the user connects to your system, they're expecting a response immediately. But if it's, as I was saying with the user service, just a notification that, hey, this user just registered to our system, do something in the background, like create an email campaign or something like that, or send out an email, that doesn't have to happen in real time. It's okay that that takes maybe a few minutes or a few days, whatever. So there that's usually the case where you want to use a message broker of some sort. But it's always a way off how you want to architect this a little bit, and it's usually very specific to each of the domains that you set this up in. So what I want you to take away from this is that an ESB or an enterprise service bus or a messaging broker or a queue, call it whatever, like the foundation idea is the same thing. You have such a large distributed system, a microservices architecture, if you will, that has grown to a point where it becomes impractical for every service that needs to talk to the other services to know about where they are on the network. Because if they need to know all these IP addresses and call each of these services, there's so many problems with that. One thing is maintainability. It's super hard to remember to always keep those lists of URLs updated. It's also super hard to make sure that every call that happens is going to happen and not fail or something like that, and then you get inconsistent states, and that's just a big shit show where you have some services that have the data and some services that don't have the data. Don't do that. So that's where a lot of people in enterprise level development and working with SOA system, they usually introduce something like a messaging broker system. Kafka, RabbitMQ, ActiveMQ are very popular products in this space, and it's very common to see this at the larger scale application development levels. Have a great day.